Question 4 is a tricky question, not least because of the wording of the question. We've got a car accelerating uniformly along a level road. Air resistance is negligible. It travels 12 meters in the second of its journey. So in a confusing twist of the English language, we're meaning second as in the one after first, and second here as a unit of time. The question is asking us how far does it travel in the fourth second of the journey, the fourth unit of time. So if I begin by sketching a velocity time graph, it's probably the easiest way of starting here. And a velocity time graph with a constant acceleration will give us a straight line. In total, we're interested in about 4 seconds of the journey. So let's mark on the other seconds. And divide up our journey into seconds. Now, we know that in the second second, it travels 12 meters. And we know that in the, and we want to find out how far it travels in this, the fourth second, first, second, third, fourth second. Now there are a few ways you could approach this related to the areas under the graphs here, which are representing the distance traveled, the displacement of the car. But the way I'll approach it is by considering the midpoints of each of these seconds, because if you draw a line across here, the actual instantaneous speed at 1.5 seconds is going to be equal to the average speed over that second. So we can say that the instantaneous speed at 1.5 seconds v is equal to the distance travelled in that second. So we're finding here the average speed of that second, which is 12 meters, divided by the time over which it takes to travel that. Now be careful here, the time is not 1.5, the time is 1 second. That's the time it's taken to get from second 1 to second 2. So that gives us a velocity of 12 meters per second on average in that second, which is also the actual velocity at 1.5 meters per second. Now we know that piece of information, we can then use suvat to work out the acceleration of the car, which is absolutely critical to us finishing this calculation. So under beginning suvat, let's write out suvat. We're doing suvat here over the entire journey from 0 seconds to 1.5 seconds, because that's a couple of points that we know enough about. So we don't care actually how far the car has travelled in total in that 1.5 seconds. We do know that it's starting from rest, so its initial velocity is 0. We do know that at 1.5 seconds, the final velocity, is 12 meters per second. We are interested in finding out the acceleration, and we know that the time it takes is 1.5 seconds. So we can use v equals u plus at and rearrange to get a is equal to v minus u divided by t, which will give us 12 minus 0 divided by 1.5, which is 8 meters per second squared. Now to work out the distance travelled in this fourth second, we need to do a very similar trick. We need to work out what the velocity is at 3.5 seconds, because that will give us the average velocity over that entire second, and hence from that we can work out the displacement. So at 3.5 seconds, we can use suvat again. Once again, we aren't interested in the total displacement. We know that the initial velocity is 0, because it's starting from rest. We're interested in the entire journey here from 0 to 3.5. We are interested in finding out what the velocity is. We know that the acceleration is 8, we've just calculated that, meters per second squared. And the time we're interested in is 3.5 seconds. Now again, we can use V equals U plus AT. U is 0, A is 8, and T is 3.5. And that will give us a velocity of 28 meters per second. So the instantaneous velocity at 3.5 seconds is 28 meters per second, which means that the average velocity between 3 and 4 seconds is 28 meters per second. So we can again use speed, distance, time to work out the distance traveled in that time. So the distance displacement S is equal to the velocity multiplied by the time. The velocity is 28 meters per second. The time we're interested in is from 3 to 4 seconds, so that's 1 second. 28 times 1 is, of course, 28 meters, which is answer A. Thank you for watching this video from Cowen Physics. If you found it useful, please like, subscribe, and visit cowenphysics.com.